Right, this video I'm going to open up our old microwave oven. Now we've had it for many years. It's finished. It's been lying in storage for about probably over a year now, and it's just time to get thrown out. But before we clear out the stuff and chuck this, I'm going to take the covers off and have a look inside it. I'm going to show you what it's like inside the microwave oven. So as a point of safety, before you open these things, you've got to be absolutely sure that there isn't any current electric that's still stored in the capacitors. There's a big capacitor inside there that can store thousands of volts. So my advice is not to open these things. Don't attempt to open them if you don't know what you're doing. Now, my dad's an electrician, he's an electrical engineer, he knows what he's doing, and I've took advice from him before I open up this device. It's not been powered up for over a year, but these capacitors could still carry charge. Now I'm going to ask my dad to quickly demonstrate what you should do to discharge a capacitor before you start touching anything inside. So I'm making that very clear. Don't take the covers off these things unless you know what you're doing. They're very dangerous. They operate at thousands of volts. So before I take the cover off, I'll show you what the microwave on the outside, the model of microwave, to give you an idea what it is before I start disassembling it. Right, so this was the microwave that we used to, well, we still own. It's no longer in use now. It's been replaced. It's an 800 watt power. Unfortunately, the glass dish is not there anymore. And the model that's the specifications. Murphy Richards, that's all the specifications, that's the warning signs that you really must read that and adhere to it for your own safety, because as I say, these things have voltages up into the thousands regarding the likes of the magnetron and that. There's a big powerful step up transformer in there. So that's the actual model, the make and the specifications as well. So I've been fascinated with microwave ovens since I was a kid, since not long after they came out in the late 70s. We got ours in the mid 80s. I was only 10, 11, wasn't it? Just I think that was 1984, 1985, so I was about 10. And when we got it, not that one obviously, we had a Sharp microwave. It was 650 watt, and I was absolutely fascinated in how it worked and everything. When we got it, I was just constantly asking my dad questions about it, how it worked, and I used to watch the microwave operating. I even used to build makeshift models and pretend, put all the circuits and all the transformers and everything. I used to create and build all that myself, just fascinating, and I still am, amongst other things as well. But the microwave oven really did have I was very interested in. I wished I never really took it up any further, but it was, as I said, it was 1985, so I was about 10. I was 84, 9 or 10 I was, and I was really into it. And then when I started high school, physics was my favourite subject, and we got taught about how these things worked. As I say, I wished I went further into it and really studied it more in depth, because like I said, nowadays your Wi-Fi and mobile phones and all that use basically microwave energy to relay signals and transmit over long distances. Well, they relay it over stations. 5G doesn't transmit as far, I don't think. That's why the alarm, is it? Well, anyway, there's more 5G amplifying points, like say, I've heard. Don't quote me, but no, I won't even go into that. But basically, your internet, Wi-Fi, and all that uses microwave energy to transmit. So, but The microwave oven is really what it does to heat food. It's not like your conventional oven where you put something in it, turn the thermostat to cook from the outside in using the convectional infrared element. The microwave cooks from the inside out. It uses the radiation, the microwave 2.45 gigahertz frequency of electromagnetic radiation to penetrate into the food, where it will excite the water-based molecules, and it will go from positive to negative, very quick at that frequency, something like that anyway. Just as a dielectric force or something, I don't know. I'm not 100% sure, but basically, very basically, from my understanding, that the molecules will be moving around at that frequency, which will create friction inside the substance being heated, the food, the water-based food. So as the friction builds up, it begins to, temperature will start to rise, and it will begin to cook the food from the inside out. And then you've got the steam thermals that will conduct the rest. You know, as it heats one point, obviously the steam will have heat energy in it, which will build up inside the cavity, inside the oven, which will obviously heat the temperature inside of the oven as well, 100 degrees centigrade. I'd say I'm not an electrical engineer, but I wish they did take it further. But basically, it's just they use that frequency at 2.45 megahertz or 2.45 gigahertz, something like that, 2.45 something. That's the optimal frequency that they use to select that to penetrate through meat to get into the food to heat it up. And the radiation, the electromagnetic microwave radiation, comes from the device inside there called the magnetron. That's what converts, well, that's what produces it. There's lots of videos out there that go into the scientific depth that will explain it a lot better. But the magnetron is the main component inside there that will produce the actual electromagnetic radiation. And that will then, the radiation will bounce around inside the cavity, and it will be sort of aimed at the food. So it's electric. The actual metal will reflect the waves back and forth in there, and the food that's been turned round on the platter will be bombarded with the waves that are moving around in there at that frequency. So they will be absorbed. The food will absorb these microwaves, and the energy in the microwaves at that frequency of 2.45 gigahertz, this is 2.45 million hertz or something, million hertz. And I really am rusty, but it's actually on them. You can Google it up, it's on the back anyway. And there'll be the labels will be inside the specifications will tell you the exact frequencies. But that very high energy frequency, well, the power is 800 watts of that frequency, and that will heat up it will excite the water molecules in the food. And as the molecules are moving, they're rubbing against other molecules, and that causes friction, which causes a build-up of heat, which will effectively cook the food with the energy rating of 800 watts, because it's an 800 watt power output. So very, very roughly, I'm no expert, and don't quote me, this is just for this is just my understanding of it. I'm not an expert explaining it. Just roughly how it works, just briefly. It's totally different from your normal cookers, your ovens. Well, it's a cooker, it's a microwave oven cooker, but it's not like your conventional cooker that uses infrared heat that comes from the element, which heats the inside of heats the air inside the oven, and that air temperature will reach it's aiming to reach the temperature of the element. So once you set the temperature, the air will then heat the food that's in it from the outside in. That's what a conventional cooker oven works. It's just the heater element that heats the oven cavity, cooks from the outside in. Whereas a microwave, in contrast, the microwave uses the electromagnetic radiation, which is the microwave at the frequency of 2.45 gigahertz. And that energy is penetrating through the food, and it goes into the food, and the actual movement of the molecules caused that's been induced by the microwave frequency. The movement of the molecules, because food's made up of lots of water, or the water-based food will be made up of millions of molecules, so they're all basically going to be moving around, excited by the electromagnetic radiation. That then causes friction, because the molecules are moving around, they're rubbing against each other, and that generates friction, that generates heat, which will cook the food to the using 800 watts of energy. So that's the best I could do. So anyway, I'm going to get the covers off and I'm going to show you what it looks like inside of our old microwave oven. But before I do, I'll ask my dad to come down here to show you how to discharge the capacitor that may still contain thousands of volts that must be discharged before you start tinkering around inside it, because these voltages are lethal. So that's anyway. Just before I do that, the magnetron is, in this instance, is behind this formica cover. The waves will come out, the microwave energy will radiate out from there. It'll reflect all around inside this cavity, including the mesh door. That's got a mesh here to stop it from coming out. So it's all going all over the place. The food's turning on the motor driven platter, and as it's turning, it's getting subjected to these high levels of microwave energy, which when it hits it, the food's absorbing it, and when it absorbs that energy, it causes the molecules inside the food to become, well, basically vibrate the molecules. It'll start to resonate with that frequency coming out of the magnetron, and as the molecules are moving, vibrating, it's generating heat because the molecules are rubbing against each other, and the rubbing against each other generates friction, which will generate heat, and that energy from these molecules being moved is coming from the 800 watts of microwave energy coming out of this part of the microwave, which behind there is the magnetron. So these other vents take away the steam. Obviously when the food starts to heat up, the steam becomes, all this becomes filled with steam, so it's got to suck some of the steam out here and out the vents at the back. So there's a fan inside there. There's a fan to suck the steam out and expel it out the back. There's also a fan in there to keep the magnetron cool. There's a motor down here to turn the glass turntable, which will ensure that the food's getting cooked evenly, because that's where the waves are coming out of them. It'll still hit around the whole cavity, but they're concentrating out of here, they're coming out of here, so the food's got to be rotated in order to get cooked evenly. And there's also a light in here as well. The glass door here, plastic, that allows you to see through it. This mesh keeps the waves, the electromagnetic radiation, microwave radiation inside of here. At least that's what it should do, and the seals are meant to keep the electromagnetic radiation within here. I've heard of leaks before, so it's not a good idea to get too close to these things. You know, it's maybe not, just in case it does leak, you should get it checked. It shouldn't leak anything out, but if it does, it wouldn't do your health any good, because it causes problems with the cells in the body if you come into contact with, well, if electromagnetic microwave radiation makes contact with your cells, it causes problems. I think cancer, it's carcinogenic. It's a carcinogenic. It induces, may cause cancer. It's not good for you, it's a health hazard, so the electromagnetic radiation's got to be kept in there. I mean, if it leaked out to the point where you would start feeling it, well, and it's a serious leak. So all your settings, that's all your controls, you know, that's defrost, medium, low, high, etc. That's your timer. There's a bell in there as well, just to tell you when your food's cooked. So some microwaves have them up there, the magnetron outlet up on the roof. Our old Sharp microwave did anyway. We've had many before that. We've had many microwaves after that Sharp. The first one that we had was a Sharp microwave, 625 watts. I think that was back in 1984. So, special door locks and that. Make sure the doors don't open when it's in use, so it's firmly. There's things here to be read. If it will go in focus, which it won't. There we go. We're going to whip the cover off it. Dad will come down and show you how to discharge the capacitor. To get the back off, or the top off, you use a Phillips screwdriver. So I'm going to take this and remove the cover. Right, so this is the capacitor that you've got to be very wary of. So my dad will show you how to, what you should do to discharge. This is how you discharge, this is you're explaining how to discharge a capacitor then.
Right, as was mentioned earlier, this is a high voltage capacitor. It can be up to and over 1500 volts when it's peak charged. As you can see, the two connections are electrodes on the capacitor. They hold the voltage, are surrounded by insulating tubes. That's to prevent finger contact or anything accidental when you're working on it, if anyone's servicing it. They also have insulated push-on connectors. Now, the only way to really discharge anything like this safely is to use a proper CE certified capacitor discharge pen. There are other ways of doing it that qualified electricians and electronics people similar to myself who will discharge it in a different manner. But we always use pens when they're available. And I'm not prepared to explain any techniques that someone who doesn't understand the full dangers that can be encountered when dealing with these capacitors. So I will not go into detail on how to make ad hoc discharge circuits for these things.
There are websites, isn't there, and stuff online?
There are websites online. I do not recommend going into them at all unless you're a qualified electrician and know what they're doing. If you're not, use a proper discharge pen and follow the instructions that you get with the pen.
Yep, yeah, that sounds fair.
You can buy these pens for under £20 or thereabouts.
Right, okay. So the capacitor was fully discharged and it was therefore safe enough to explode inside the microwave.
Yeah, what I will say is, in all of these capacitors, there's an integral discharge resistor built in to the capacitor, but you cannot rely on that. It may fail. This is why you have to follow a proper discharge procedure before you even consider removing it and working on it.
So what was that you were to say there? There's something else.
What I will say about that, the integral discharge resistor, it's a very high resistance obviously, so the capacitance isn't affected by discharging it too quickly. So it's a very high resistance, say maybe 10 megohms.
10 megohms. Yeah.
Which means that when the power's off of that capacitor, it will take a period of time before it discharges it safely. So give it a good while to discharge before you even consider using your discharge pen.
Yeah, yeah. There's been a stored in that cellar for about a year anyway, at least a year. So this is the magnetron device here. That's what actually produces the microwaves. This is the big step up transformer that takes the mains voltage from the plug, 240 volts, goes through the circuitry. It's inline fuse for the capacitor, but it steps up the voltage from the mains using this transformer from the primary windings, and it comes out at very high voltage at the secondary windings into the thousands, which is what's required by this device called the magnetron, and that's what's connected to the side of the microwave, the actual oven cavity, and the waves come out from there. There's a beryllium oxide material in there that you don't want to touch, by the way, so you've got to be extra careful with that. And maybe see if we could remove that. The bell is the screwdriver to it's the bell. As I went earlier, that's to make the transformer, step up transformer, mains voltage comes in from the mains, goes through this, I don't know quite sure, what's this circuit board doing? What's that circuit board about there?
That'll be the interference suppressor.
Interference suppression circuit. Right, so that's so that everything else, other appliances outside the microwave doesn't get affected by it. So it's just so that it keeps the mains, it doesn't cause any problems with the electrical supply to the other electrical equipment in your house. This is a noise filter, yeah. This basically doesn't cause any feedback problems through this and then affecting all your other appliances around the house. This is what this circuit here is for. It's a filter circuit to eliminate interference produced by the workings of the high voltages in the air. So it's a 9-line fuse. What would that be for then?
Well, that's to protect the magnetron.
Let's have a look. Protect the magnetron.
It's just to protect the circuit, because you can't get shorts.
Yeah.
And it's just to limit any current that might be, fault current that might be there. A slow acting fuse. Really, that's it.
So that's the protected magnetron. So there's the bulb as well, that's tucked in this bit here. That's the bit that you'll see. I'm going to get that to zoom in so you can just see the bulb for lighting up the inside of the oven. As I showed you earlier, that's the bell. This is all your door mechanism gearing. There's a safety lock switch here as well, just to make sure that it won't operate with the door open. Make sure buttons up. What was that diode for again? What was that for again?
Part of the magnetron circuit.
Ah, right, part of the magnetron circuit.
You need the DC on it.
Yeah.
For the magnetron to work.
Alright. Okay.
So high voltage magnetron DC.
So that's the fan. That's the fan. There's 2 fans in there, I think. No, there's a motor. That's the fan for cooling the magnetron. Blows air, sucks air from the back, blows it through the magnetron, cooling fins. Yeah.
That's the thermal cutout for the magnetron.
That's the thermal cutout for the magnetron. Right. So I'm going to maybe remove the magnetron. Well, it's fortunate this thing is going to start to rain. I don't want it to rain. It might be. This thing here, this would just come off. That's for mica. So we'll just peel that off. Exposes the waveguide. So I've just pulled it off. That's the actual.
That's what funnels the magnetics into the oven.
Yeah, that's right. Yeah, it funnels it in. It comes out of there. That's just to stop the dirt and steam getting in, isn't it? This.
Basically, yeah, because you don't want anything going to short out.
Aye, because the steam will just. So this for mica insulator cover, mica. It's mica. Yeah, that just stops any steam and sparks. No sparks. Splurts of food when it explodes. You don't want it going in there and getting into here and causing problems, especially water, because it could, with high voltages and water, could as a recipe for short circuiting. This is another thermal cut-off switch. Thermals. Is that not like for the earth? So how do you earth? There's the earth and straps
That's
there.
going into the filter. That'll be into the circuit. Then this show this. Let's see what it's set. Temperature inside the
Just
cavity of the oven.
temperature sensor then.
Yeah. Should tell you the temperature on it. Can't read it for here. Maybe.
It looks like a diode or a transistor or a B105. Yeah, it looks like a. Well, actually, no, I thought it was like a MOSFET transistor, but it's just the fixing plate is shaped like it, isn't it? Oh, I know. It's a bit cold, yeah.
This is known.
Oh, sorry,
Yeah, it's just a straight through bimetallic cutout.
oh, right.
Temperature cutout.
Yeah. So that'll vary with its resistance due to temperature then?
Strip.
Oh, bimetallic
Just
strip.
clicks
Yeah.
on and off.
So like, it's just like a thermostat on a car that
It
heats
is,
up with
this
a
is
little
what it is.
thermal cutout. So it heats with the heat, it expands something in there, it cuts the power. Yeah, bends with the temperature.
You might be able to read the temperature setting on there because
Aye, yeah, I showed him the bulb. So it's getting a bit cold here, but I'm good. It's starting to rain a little bit, but I'm going to hang on for a bit. And I want to remove the magnetron. I want to have a look at that. I know I want to have a look at the motor as well, so I'll do my best with that.
this
There's a
won't
lot,
take off.
a lot of stuff to take. Let's show the underside. I'll get rid of that. There's a motor for the turntable inside there, which I'll show later on, but I'll get the magnetron off next. That's the next one that I want to remove. In case you're wondering why I'm doing it outside, is that I didn't want to mess up the house with all these. This was sitting in there for about a year, it's all filthy, and it's just, there's more light outside actually to see into all the small parts. So it's more beneficial to do this sort of stuff when videoing outside. It does make a mess of the house and there's more light, because when you're in a house you're going to get the main light and you're shining torches and everything into it, and it's just more uniformly lit up outside for getting to see into all the small areas inside these things. Right, so you just start screwing this then. I feel the magnet in there actually. I can feel it's magnetic. It's a magnetron. You can see how magnetic that it is. That screw is just held on with a magnet. Hence the name magnetron. The wave guide. So because this microwave's finished, I could just basically pull these wires off, just remove the whole unit. Right. Well, there's another wire at the bottom. So it's a plug connector. So that's just plug connectors and spade connectors, and that's the magnetron assembly unit out completely. And just to show you how magnetic it is. So this is the actual magnet bit of the magnetron.
Two ordinary magnets.
Yeah.
Either side one. Create a magnetic field.
Mhm.
And then the cavity of the magnetron.
Yeah. So the waves, it causes the wave oscillation then at that frequency, does it?
Yes, it does. The frequency is determined by the design of the cavity.
Right. Yeah.
It's almost all standard ones for microwaves.
Is that the bit that's that hazardous, that white bit there, is that beryllium stuff or something? Yeah, so there could be hazardous stuff in there, beryllium oxide or something. That's the... Yeah. So testing resistance of using a meter.
Beryllium oxide is an insulator.
So that's just to check the resistance. It's not got any voltage in it or anything, just to see if it conducts electricity or not, using meter. So the meter is basically producing the voltage, which is for measuring resistance. That's where the actual microwaves come. It comes out of here and hang on, it's rushing a little bit because it's starting to rain. I have to continue on in there. I'll just wait and see what happens. Hang on. Rain, typical, starting to rain. But yeah, as I was saying, that's where the actual microwaves come out of here, and from there it goes through the side of the oven, which comes into the thing. It's getting a bit wet. My dad's just going in just now. It's starting. I'm going to hang on for a bit, and I'm going to continue on having a look in here. Go through the best I can with what I know. So it causes a wave pattern that, if I remember, I'll put a link in the description to a brilliant video that explains the technical terms on how the actual magnetron works. It shows graphic illustrations. I will remember to add that into the description because it's a very good descriptive description of how it works, how a microwave actually works. And that's me just repelling this from the magnet because it's magnetic. It's the main component anyway, so I've dissected that out of this oven. The next thing I want to show you, well, I'm going to be showing you the bulb. Okay, let's pull all these split connectors on the it's easy. There we go. Just sits in there. It's the actual bulb, the fan, as I've shown already. To get into the motor, I'd have to see if we could remove the base. Before I do, remove the big transformer. 4 screws at the bottom. Oh, it's actually bloody freezing. You know this, for coming into blooming April, it's like sleet. It's freezing. It's ridiculous how it's so cold. Absolutely ridiculously cold for this time of year. It was sunny not that long ago, and it was getting all wet and miserable. So everything so far has been Phillips screws, which is a great help. Now, these transformers weigh a ton, by the way. Hefty device. So the 4 screws removed, and secures the transformer to the chassis of the microwave, which should just start to come out. Weight connectors for the primary or secondary windings for the transformer that need to be removed. That's how the transformer works. It induces a voltage through one set of one set of windings, and due to the transformer, the number of windings on the secondary side of the core will determine whether it's a step up or a step down transformer. The power will be the same, it just converts the power from either a high voltage to a low voltage, or a low voltage to a high voltage. If it goes to high voltage, it lowers the current in respect to the voltage proportionally, because it doesn't produce energy, it just converts energy. So you get higher voltage but lower current, and vice versa. Right, good old brute force does the trick. Just ripped it out. So there's a bit of the specifications of the transformer. It's heavy. It's a big iron core. I'm not sure which side's which. There's a primary and secondary winding anyway, and that will be used to transform mains voltage into high voltage in order to operate the magnetron. And the capacitor is basically a storage system to keep a steady power supply to it, so it kind of like gives it a smooth power supply. So this voltage is in there, so if there are any fluctuations in the mains, it doesn't cause it to alter, you know, to mess around with it. So it needs to have a smooth power flow into the system, and the capacitor acts as a reservoir So if there's any fluctuations in the mains, then this kind of like suppresses it. It keeps it smooth. That's right, I guess. So I'm going to take the fan assembly up now. It's the couple of Phillips screws on the back. These also have like a sort of serrated locking washer as well fitted to it. Because there's vibrations, you know, this is moving, so it could set up an oscillating vibration system that could work its way loose. If things are moving, like, you know, they're tending to generate vibrations because there's a moving part, you see. So the locking washers there just to ensure that it doesn't basically work its way loose. All the rest of the stuff doesn't move, there's no other moving parts other than the motor for the turntable. So I think that's why we've got locking washers on this, because this is actually a moving part. And moving parts generate vibrations. And vibrations loosen things off. So you've got resistors, I recognise that would be possibly the speed control resistors or something on the back of this motor assembly. I'll disconnect the wiring. So that's the fan motor assembly. It's the blades, that's just suppressor circuit where I just simply cut the wires just so I can get it all quicker, save more time. So that's the windings for the motor and the magnet on there, I guess, is it? Maybe not, I don't know. Induces a transformer type motor anyway. So I suppose I can move the control board. There's a couple of Phillips screws as well. See if we could remove that for you. So that's a bell. We can fill that for you. So there's obviously something that's... Oh, you can just see it. You can see the mover. It's like a spring or something in there. It's... Oh yeah, there's a spring there, look. So I just saw it. Ah, there, there's a better view, look. So that's that. Switch gear. Oh, there's... Oh, it works. It must move something in here then that's causing the... So it's not directly a switch, that doesn't go into electrics, that's moving the mechanical lever behind here that's operating something in this assembly. So this sort of timer, bell and temperature controls all in this assembly, and this switch is only operating a mechanical means that's operating something in there to cause the you know, adjust the settings. And that's the connectors that came off with the spade connectors. They just, electrical spade connectors, just push fit on there. And then you've got the door locking mechanism. Right, so that's that removed. I suppose the door interlocking mechanism, we can remove that next. So there's, again, it's got these locking washers which bite into the metal for to grip onto the metal so it doesn't work loose. Because this door's open and closing all the time, it's going to have forces on it, you know, it could shake it loose, so they put the locking washers on them just to make sure that everything's... And another thing as well is that as the microwave oven being metal, it'll heat up and contract slightly, which causes movement as well. So these locking washers tend to make sure these screws don't work loose, because you've got thermal expansion, because these things get a little bit warm as well when you're cooking, and then it cools down again, and that is movement which causes things to work loose. There's just one set of wires at the bottom just to come out. And these wires run down to the motor at the bottom there. So there's the door locking switches and that, because these switches here, that's where these will go into. I might even take them off if I could. I don't know. I might burst them open and see what's in there. But that they're locking things. These lugs have got to make contact with these switches before the thing will operate. There's a safety device. There's a one for the bottom lock and one for the top lock. And there's this other thing here. Not 100% sure what that black thing is. I don't know what that is, but it's something to do with the locking mechanism anyway. So the rain's off a little bit. It does back down here again. Just he's gonna hang on. He's gonna show us
Of those things, one else in metal.
that bit here on the magnetron, that gold bit. It's the radio frequency filter. Is that right? Yeah. It's a radio, that gold bit, that gold ring there in the centre.
Stop emitting to the air.
Yeah.
Because it interferes.
So it's just a filter. Because if that wasn't there, it would interfere with all the other radios and stuff. Closer up view of it. What was the other material you were?
No, everything in different shades. It's a flat, hard porcelain type substance.
Is that it there? That white stuff? Is that the
No.
brilliant stuff? No.
That's a radio frequency.
No, that white bit. That white. That's like porcelain.
It's quite possible. So sorts of it's high temperature and it's used as a heat sink and lasers.
Yeah, I won't touch that stuff.
It's not so bad when it's intact, but if it gets damaged, scuffed, scraped,
Yeah, it comes
it
off.
releases.
Bit like asbestos.
Well,
Behaves like that.
no,
Yeah.
you can't see those as such.
It's annoying what that's
It's
a cover.
absorbed in the skin.
That there, by the way, was put on to stop it from vibrating against the case, the metal case, because that transformer, this magnetron, sorry, it will cause a buzzing sound, won't it? And that black thing there is just to prevent the case.
Probably just to keep
Dampen it.
it spaced. And
Yeah,
keep it
Oh, there was something else I was going to ask. See that there? What's that black bit there?
I didn't have glasses, Christian. Let me have a look. That's a micro switch.
Ah, yeah, they two are micro switches, but what's that black one in the centre?
That one there.
Yeah.
It's a micro switch.
Is it?
It's a door interlock.
Oh, but I thought. Oh, right, aye, yeah, but.
When the door, you've got the hook on the door.
Yeah.
There's pushes in there. And operates there.
Oh,
Operates the whole light.
yeah, I just thought these micro switches physically, actually mechanically touches these micro switches to ensure that the door's closed before it operates. Right, so that's how the door works in. So basically I've just put this in there temporarily. You can see how the door mates up with these micro switches. So the micro switch assembly, these holes I've got to line up there, that's where it was. So when you close the door, you want to close that door and see it. Should just fit back in. Yeah. And then these lugs make contact with these white micro switches. And that then tells the rest of the circuit that the door's shut before it operates the microwave. So it's a safety switch basically. So I'm going to take off the base and I'm going to have a look at the electric motor that turns the turntable, the glass turntable inside. It's that rain on again. So Dad's just doing the sensible thing and go in the house. Like I say, I'll just continue on with this, even though it's raining. So there's quite a few Phillips screws to come out in order to remove the base. There's quite a few. We'll get there, slowly but surely. Turn the unit around and do this. So just as well, it's on its roof. I could take the two screws that hold the door on as well. So I'll remove these. The door fits on with a couple of Phillips screws. This this end and one at the top of the unit. Just over, just sort of sangles between there. There's a pivot there that needs to come off. Screw which removes that pivot. There's another one there actually that needs to be removed before the door. Just a bit of stuff. So, door's removed. There's the hinges, top assembly hinge. Bottom one, which is on the table. And now we'll just remove the rest of the base screws and remove this. And this now exposes the motor for the turntable. Synchronous motor, 30 volts, it's 5 to 6 RPM. 3 watts. And I think I'll remove the motor as well. Again, it's a Phillips screwdriver. This screwdriver, by the way, this screwdriver is totally disassembled. All of that. Just this one screwdriver. One screwdriver does all that. See, they've used the same screw throughout, which makes it easier for assembling and disassembling. So it makes it so much easier when there's one screwdriver can do all that. And that's the hole for the magnetron, by the way. That fits in, like, that's where the microwaves come out of that hole there. And that fits in like such. Just, you can see where it goes through. And from there, so the microwaves go through that and come out the other side, as you can see. And this cover here just basically goes over there as a protective cover. This is made out of an insulated material. It's just sort of like a cardboardish sort of. It's dead easy to flex. It's not much to it really. It's actually broken, but it doesn't matter now. So, where was I? Yeah, I'm going to remove this motor. Now, there was a screw missing there. I don't know when that, I never took it out, did I? I don't think I did. I'll look back in the video, but maybe you did. Probably did. Right, so that's the motor removed. It's got some, probably a set of gears in there or something, because it'll be a reduction gears, so that it'll be high torque but low RPM. Because the weight of the platter and the food on it will weigh quite a bit for a wee motor. So the motor in there will spin faster, but it'll go through a set of gears, I assume, which will reduce the speed but will increase the torque accordingly. Because it's got to obviously shift it. A big heavy turkey, for example. And that's it really. That's just your mains cord coming in the back. I'll remove that as well. That's just the grommet fit. Oh, and you've got your earth leads as well. That earths, what they do is that earths all the metal case. So if there's a short circuit from any of these wires, if a wire came out or broke it, or insulation broke down and any of the high voltage touches the metal casing, this earth lead will run the voltage to the plug and it will cause the fuse to blow, or it will blow the chip in your meter. It's just a safety. So if any short circuits happen, your earth leads will trip, basically the current will go down, blow the fuse, blow the chip in your meter, and should protect this from being, you know, the outside becoming high voltage, or any of the metal bits that you come into contact with. That's what the earth does, it earths it. So any breaking wire or anything like that will cause a short circuit via this earth wire. It'll trip the switch in your meter box or blow the fuse, and you've also got a fuse in the actual plug as well. Yeah, you've got a fuse in there also. So Right, so that's pretty much this microwave completely disassembled. So that's the core. That's the main core of it. This is the chassis, the bottom bit where the motor fixes to. The door, there's not really much you could do with the door. I suppose I could break it open and see what's in there, I suppose. So I've introduced another tool to the destruction tools I've got. This is a big screwdriver. I'm going to use this big screwdriver to pry open the locking mechanism, see if we could see a look inside there. So we're going to have a look in there. I'm going to use this big screwdriver to somehow pry something off and have a wee nosy in there. Bit of gentle persuasion. Now let's just put it in context just how big the screwdriver is, by the way. It doesn't even fit inside the oven. It's about the same length as the microwave itself. So that gives you an idea just how big it is. It's massive. Plenty of leverage. It's a flat screwdriver to get into pry it. And big size 12 foot. Big size 12 feet also help. And that was one of my nicknames, boat feet, when I was at the school. And I need boats for today's weather. Pissing me rain. But anyway, I've got some of the seal, the door seal off to show the locking mechanism. So there isn't an awful lot, but this seems to be the main bit. This microwave's never going to work again, so the seals, these things have got to be imperative that these things are in good condition, because like I said earlier, if any of these microwaves leak out while it's in use, it's a health hazard. It can, from what I've been told, that could cause cancer. It's a carcinogen. It causes, if you come into contact with microwave energy from the leaking microwave oven, I believe it could cause cancer. So it damages the cells. That's what I heard. So these seals and everything else has got to be in good working order. And I think this is the door seal that's the main one. Don't quote me on that, but could be. And as I say, the door itself, the locking mechanism, this way just a spring loaded spring. These like pry up, there's like little pry bits there. I could remove this to replace there's like lugs there that will pry up. I could remove the actual glass assembly or the plastic assembly. See if we could do that for you. At least that rain's going off a little bit for now. Anyway, I've got this door bit prized off. A bit of gentle persuasion. I'm putting on plastic gloves as well because there's sharp metal involved. I've removed the door glass assembly and mesh. It's the mesh. That is actually the metal bit. The mesh. That's what's reflecting the waves back inside. That's keeping the waves in the oven. That's regarded as part of the door seal mechanism, I'd assume. And the plastic bit that you see through is this, without the mesh. And it is made out of like a glass, I think. Yeah, that sounds like glass to me. There's a very tough perspex, one of the two, probably glass, because I think perspex might be prone for scratching. Certainly would not want to see a microwave in operation like that without the mesh bit. So that's part of the seals, which is where the glass bit is probably just adhesive. It'll be adhesively stuck to the rest of this dress trim. This is like a stainless steel coating maybe. This is for the Murphy Richards. It's a finish and touch basically. This Right, so I think I've pretty much opened maybe I don't think there'll be much behind that, to be honest. There's not really an awful lot there. Oh, and the case, that's just a lid. Not much really to see in here. It's got the circuit diagrams Dad was looking at earlier. And this weighs a ton, by the way. It just shows you how heavy that weighs. Watch this. Right. This demonstrates just how heavy this transformer is. Right. Bloody heavy. That's the most of the weight. The heaviest part. This doesn't weigh as much. My magnetron isn't really that heavy, but that's the main component that produces the microwaves. And as my dad explained earlier about the radio frequency filter on the front there. So magnetron, transformer, fan assembly with the suppressor circuit on the top. Switch gear with the bell and the door interlocking mechanism. Oh, no, actually no, it's not. The door interlock mechanism is here, which has got the wiring harness to the light as well. It's the door interlocking assembly and micro switches. And the deadly capacitor, which could be deadly if it's not being discharged. That will store 2.1 kilowatt, 2100 volts. You don't mess around with these things. They store store enough energy in there to kill you, so you really have to treat that with respect. You don't open any of this up, as I say, unless you know what you're doing. Lethal volt, just to make sure that it's safer to take apart. That's the motor for the turntable, and you've got a whole load of Phillips screws. Everything was held together with Phillips screws, also a hex bolt as well. So if that screw around, you could use a hex bolt socket to get that out. All Phillips. I've just used a flat screwdriver, pliers and stuff, just for gentle persuasion, just to pry things open and whatnot. The plug, there's not really much in there, that's just the mains cord. And you've got your chassis, the base plate, that's where the motor fits to. There's a few clips and hinges and clamps, that's the clamp for the capacitor. That's the chassis, the base of the microwave, that's the door hinge, door seal assemblies, actual front door assembly, the core, the actual microwave oven internal cavity, bodywork, casing. This is the internal bit. You don't see this bit, this is covered by the breast panels apart from the back. It's actually quite ironic really, because I was saying that the back comes off. The back doesn't actually come off as such, it's the top cover, the top case comes off. And that's really about it. So what I'll do is I'll put this into a nice neat pile on the table, and I'll get some stills, photograph stills, and pretty much round off the video from there, because I've done all I could do with this. So. Right. So. Right, there you have it. There's everything that's inside our old microwave oven. That's the model as you would have seen at the start. So there. And the main component for the microwaves is the magnetron. It's cooling fins where the fan blows, where this fan blows cool air through. It sucks the cool air from these vents from the back. It'll suck air in. This fan will suck air in from the back, and it'll blow the cool air from the back through these cooling fins, and it will expel from one of the side vents. It's basically just to cool this magnetron down. That's the business end of the magnetron. That's where the microwaves come out. They come out and they go through this hole. And this particular microwave, you get some of them with the magnetron at the top. Our old Sharp had the magnetron, well, probably had the magnetron in the side, but it would have wave guides to guide the waves, because you wouldn't fit that at the top, wouldn't be enough room. But the actual outlet where this cover was, so the microwaves on our old, or one of our old Sharp microwaves, came from the top. So the magnetron would have been in the side. There would have been wave guides to guide the microwaves to beam the waves down. But in this particular model, it comes out through the business end of the magnetron, through this hole, which comes out from there. They come out there and they bounce around all over in there, and the food absorbs them. The food absorbs the microwaves, and that this sort of mica material, silver to reflective waves, I suppose. That's the inside, but that there is just to stop any food spurting up and going into there and damaging this component, or any steam, because it's high voltages. You don't want water getting in amongst that. It causes all sorts of problems, short circuits, and it just, you wouldn't want, just to stop any food spurting up into there. That's all that is for. So you've got your big heavy duty transformer. As I say, that is heavy. That weighs a solid iron core. These are made up of plates. That's what causes the buzzing sound. They vibrate as the frequency is AC voltage, so it's going very quickly, 50 times a second. It's going like that, the voltage. It's oscillating, alternating, and as it alternates, these cores expand and contract, and that causes the noise, that buzzing sound that you get from a transformer. It's the plates that are vibrating in harmony with the 50 Hertz from the 50 Hertz AC voltage coming in from the mains lead, and it goes from a primary winding to the secondary winding AC. So it's step up. In this case, it's coming 240 volts in from the mains plug, steps the voltages up to into the thousands, comes out the secondary windings. That's what's required to make this magnetron produce microwaves. So that's a very important, critical component for making the microwave. The motor at the bottom sits on the chassis, turns the turntable, the glass dish that you put your food on, and it just basically turns it at about 3 RPM. Be a wee gear in there that will reduce the speed of the motor but increase the torque. So this will turn very slowly. But the motor in there, inside this, will probably spin a lot faster. But it'll go through gears to make it spin slower, but in doing so, it increases the torque accordingly, which means it's stronger. It goes slower but stronger. If it was spinning faster, you would be able to stop it easier. But they can concentrate the spinning movement into torque, so it's got to move this heavy glass platter with all your food on it, so it spins slowly. This is the capacitor. It's just basically a reservoir to store electrical charge. That's just the ratings on it. That keeps a nice steady flow of power going to the circuits inside here, because if you've got household appliances, there's things being switched on and off everywhere, and that would cause a surge in voltage in here, which would affect the running of this. It wouldn't work if it keeps surging off and on. So this capacitor gives it a nice smooth power output. It's like a reservoir. So if there's a surge, it still comes out here continually, but it stores very high voltages. You've got to discharge that with a special discharge tool before you attempt to touch them. You don't go into this at all unless you know what you're doing. That's the thing you've really got to be careful with. I'm not promoting or encouraging NB to do this, so I'm making that very, very clear. But be very careful with these things, because these are deadly voltages in there. Deadly. Okay, so next thing is the door interlock mechanism. The micro switches on there. So when these tabs come into contact with these switches, the switches will close, which means then it's detecting that the door's shut, and then the microwave can operate. The microwave won't operate unless these switches are made contact with them. And there's probably all sorts of foolproof and safe mechanisms, so you can't fool them either, just to be on the extra safe side. It'll probably be foolproof, so you couldn't trick it into thinking that it's on by just jamming something in there. They'll be quite sophisticated. That's the bulb, just to illuminate the inside of the cavity when your food's cooking. This is the fan assembly. It does two things. It cools the magnetron down by blowing cool air through these fins. It also causes the suction to suck the steam out of here, so when your food's cooking away, there's going to be a build up of steam. The steam needs to be sucked out and expelled through the back of the microwave. There are some of these vents on the top and sides, and this fan is employed to do that. That's what this is for. Cool the magnetron and to suck the steam out of the oven when your food's cooking. It's like a transformer type fan. Try this here, kind of spin it and hold it at the same time. So that's your top cover. All together with Phillips screws. I think I've covered everything. That's just a load of fixtures, various fixtures. That's for the capacitor. Load of screws and bits of clamp clips and lugs and all sorts of things that were broken off in the disassembly. And it was only really just the one Phillips screwdriver that took this whole thing apart, with the help, enlisting the help of a flat screwdriver, big massive one, just for the prying open for leverage effect, just for gentle persuasion. You wouldn't use that if you were doing any repairs on them, because this is just used to brute force to break things open so we can get into them. But this screwdriver seemed to take apart just about everything. I don't think I could open this magnetron anyway. These screws are just for brackets. This is like an air channel guide or something. The air will maybe go through there. It's magnetic, by the way. So there's obviously a big magnet there. And I think if I took these screws out, that would just remove this. This unit I don't think I could open up. There's not really, unless I bend that, but I don't know if I want to do that. There's hazardous stuff in there anyway. I don't know if I could actually get into that anyway. I don't really think there's an awful lot in there to be It's kind of like welded as well. I'd have to break seam that. I'd have to put something at I'd have to cut that open to see inside it. I don't know if I can get into that. Aha! Managed to pry it open. And that's what's inside there. Wow. Now there is hazardous materials in there I don't want to be touching, so I wonder if I could get that open as well then. I just pried it open. So I've managed to use a little bit of gentle persuasion, i.e. a big pry bar, screwdriver, and hammer. Got the back cover off the magnetron. Now I'm not touching any of that because it could be hazardous. So that's the back. as I showed there. I managed to rip the front off, and I think these bits are the magnets. Aye, they are. This here, as you can tell, it's a strong magnet. Look, you could just about lift the thing up. See that? So I didn't want to be touching that. I think it's hazardous, but it's certainly sticking to this screwdriver big time. Like, there's the cooling fins. It's just kind of like sticking on, is it? See if we can get it off. So this is more inside the magnetron. Now there's stuff in there I wouldn't touch, obviously, with my bare hands. So that's the other magnet in there. We've got another magnet I took out, which is just there. That was on the front. And you've got this rear magnet as well. That's the cooling fins and the magnetron. Runs right through. And these magnets were around it. And the bit at the back as well. There's the front cover, there's the back cover, and that's pretty much opened it all up. I'm going to have to get going because I've just noticed the time there and I've got some other things to do, so I'm going to need to just round this video off now. I've pretty much opened everything and showed you as much as I can. So I couldn't remember where I was at. I've run out of battery. I had to put it on the remote charge. Yeah, I think what was it doing? I think it was photographing. I think I photographed everything. I had to go and get the charger. It's just pretty much round the video off now. So that's it. That's the inside of our microwave oven, the Murphy Richard one, 800 watt. Like I say, you don't touch any of the borrowing stuff, whatever the materials in there. Borium or something. It's hazardous. So. Right, I've got to tidy this up, warm myself up, dry myself out. It's soaked, it's cold. I probably get my tea or something later. I've got other things to do. Right, I'll just round the video off. I hope you enjoyed that anyway. I think that's anything else to open up inside regarding this microwave. I'll open up other devices at another videos, but I think that's pretty much it. Yeah, I think I've done enough with this. I'll tell you one thing, this feels a lot lighter now. A lot lighter. A big transformer out. This is the heavy one. So I've got all my still photographs of everything. I've identified all the components. Right, so that should do it. Okay, right, I hope you enjoyed the video. Just see what else I put up on my channel, and thanks for watching. Bye for now. Catch you later, bye. it.